Today we're going to do some geometric mean using the altitude, and then later we're going to get into using the legs. All right, so there's two different things that we're going to get today. All right, so these are like the weird right triangles where we have the altitude. The altitude is, and we're going to use from the distance from C, which is at the right angle, and it's the height of the triangle using the base AB. So it looks a little weird, but we'll talk about the things that go on. Geometric mean. Okay, we're going to talk about that. That's basically when we have the same thing in the bottom on the left and the top on the right. So we're going to compare these together. BD. All right, so BD. This guy here, BD, is to CD. All right, CD. So those are the altitudes. So CD is the altitude, and BD is also an altitude, and then CD goes here, because it's the altitude, and then we're comparing AD. AD is here. So here we have BD to CD is equal to CD to AD. So let me give you a problem where you would see this. All right, so in this case, BD is this little part here. So A plus 5 over, and now this CD is my altitude. So these are my altitudes here. So this is over 12 equals 12 over, and then in this case 18, which is the other segment of this base. So the first one is part of the segment. So that's dB here. A plus 5 is the dB there. Part of that segment that altitude cuts is to the altitude, as the altitude is to the other part of that segment that it cuts in half. All right, so here we're going to do a cross multiply. We get 18A plus 90 equals 144. So minus 90 on both sides. 18A equals 54. Divide by 18. So A is 3. So A is 3. That means this distance here is 8. Okay, so that's using the altitude. So the altitude cuts it into two pieces. So we take, in that case, the first piece. Let me redo. We take the first piece to the altitude is the second piece to the altitude, or is the altitude to the second piece. And we'll talk about some other of those in class. The other one that we're going to deal with is geometric mean using the legs. All right, so the legs is what we're going to talk about now. It's a little bit different. All right, but let's use, we'll talk about these here. All right, so we're going to do the same kind of picture where we have the altitude coming from that 90 degrees. Okay, and altitude is always has that 90 degrees there, and it's coming from the vertex, which is the 90 degrees. Now in this case we have AB. AB is the whole thing. So it's a little different than last time. The whole thing over CB and then CB. So CB is a leg. This is a leg as well. So we're using that same leg. It's the leg of this triangle here, all right? So we have the whole thing, which is kind of like the hypotenuse. It is the hypotenuse over a leg equals, and then CB happens to be the hypotenuse of this triangle here. So this is CB, this is the hypotenuse. So in this case, this is not the leg, I'm sorry, this is the hypotenuse. And then DB is the actual leg. So in both cases, we have the hypotenuse over the leg, the hypotenuse over the leg. But in the first, the big triangle, CB is a leg. In the small triangle, CB is a hypotenuse. All right, so let's see if we can set this up using an actual problem. All right, so AB. Basically, we're going to use the hypotenuse, which is 8, over, all right, which is the leg, in this case is X. And we're talking about the leg of the big triangle, equals, and then we have the hypotenuse of the small triangle, which is X, over the leg, which is 2. All right, so we're looking for x. So we're going to cross multiply. We get x squared equals 16. Take the square root of both sides. X equals 4. All right, so this is 4. And that is those two little theorems using geometric mean. Okay, geometric mean is when we have, let me talk about this. We have something here over x equals x over, again, something there. Just that's the basic setup of the whole thing.